NASA has released the first images taken by the James Webb Space Telescope.
The pictures are unlike anything we've ever seen before.
On March 16, 2026, the skies above Jupiter will host a once-in-a-lifetime show. An interstellar traveler, 3I Atlas, will swing past the gas giant, blazing by at just over 53 million kilometers away. And NASA? They've got a wild plan brewing. Up there, far above Jupiter's massive storm clouds, the aging Juno spacecraft is still holding on. It was supposed to wrap up in September 2025, ending with a fiery plunge into the planet's crushing atmosphere. But now there's a bold twist. What if Juno spent its very last drops of fuel chasing history instead of death? The target? Becoming the first spacecraft ever to intercept an object from another star? No one's dared to try this. And here's the kicker. There's no do-over. Miss it, and it's gone forever. 3I Atlas is tearing through our solar system at 66 kilometers per second. That's over 148,000 miles per hour, with a path that just so happens to drift close to Juno's orbit by sheer cosmic luck. But close in space? That still means tens of millions of kilometers, a razor's edge between a perfect intercept and watching the visitor vanish into the dark. Right now, Juno's locked in a long, looping dance around Jupiter, swooping from the outer edge of its magnetic shield to heart-stopping passes just a few thousand kilometers above the cloud tops. To pull this off, Juno must break its rhythm, bending its orbit to meet the visitor exactly as it flies by. And here's the nail-biter. The burn to change course has to happen by September 2025, literally days before its scheduled death dive. Miss that moment, and the cosmic door slams shut. This is why mission planners call it a one-shot intercept, the perfect alignment of Jupiter, Juno, and a messenger from another star. A dance the universe won't choreograph again in our lifetime. To catch 3I Atlas, Juno can't just spin around and hit the gas. This thing is moving way too fast for a straight-up chase. Instead, mission planners are eyeing one of the boldest moves in orbital history, the Jupiter-Oth maneuver. Here's the idea. When a spacecraft fires its engines deep inside a planet's gravity well, right at the bottom of its swing, the burn becomes supercharged. The planet's pull stacks onto the spacecraft's own speed, turning a little fuel into a massive velocity boost. For Juno, the game plan is daring. On September 9, 2025, it would fire its main engine to dive into an even tighter pass around Jupiter. Then, just 5 days later, screaming past the giant's cloud tops at 35 kilometers per second, it would fire again, this time letting Jupiter's gravity hurl it outward toward 3I Atlas's path. The price tag? 2.6755 kilometers per second in speed change, almost exactly what Juno's fuel tanks have left. If it works, Juno would arrive on March 14, 2026, just 2 days before the interstellar visitor's closest pass to Jupiter, and it would do it with only 110 kilograms of fuel, a measly 5% of what it started with, closing in to within 27 million kilometers of the alien traveler. Getting any closer would cost way more fuel than Juno can spare. This isn't just a wild fan theory either. It's straight out of a 2025 preprint study intercepting 3I Atlas at closest approach to Jupiter with the Juno spacecraft, written by Abraham Loeb, Adam Hibbard, and Adam Crowell. Their simulations map out different possible flight paths, from single-burn slingshots to double impulse moves that could save fuel but ramp up the danger. No matter which path they pick, the margin for error is razor thin. The burns must be flawless, to the second. And once Juno breaks free from Jupiter's pull, there's no coming back. This is the Jupiter-Oth maneuver, a slingshot through the void, aimed dead at a visitor from another star. If Juno pulls off the burn, if the Jupiter-Oth maneuver actually works, it won't be slowing down for a cozy meet and greet with 3I Atlas. There's no speed match here. Instead, they'll blaze past each other in a high-speed flyby out in the freezing darkness beyond Jupiter's orbit, a blink in cosmic time. When their paths cross, it'll be violent in speed but delicate in purpose. For just minutes, maybe a few precious hours, Juno will lock eyes on a wanderer from another star system. A chunk of matter that may have formed under an alien sun, with chemistry shaped billions of years ago in a place we can barely imagine. Juno's instruments, built to study Jupiter, will be pushed to the edge. JunoCam could snap rapid-fire, high-res images, catching fine details in ice, rock, or dusty plumes as sunlight flashes across its surface. The magnetometer could sniff out traces of a magnetic field. The infrared mapper might catch temperature shifts, evidence of sublimating ice or hidden internal heat. Even the radio science experiment could listen for tiny gravitational pulls, revealing the object's mass and density. From Earth, our most powerful telescopes will see 3I Atlas as nothing but a speck of light. But Juno, streaking past at thousands of kilometers per second, could turn that speck into a fully realized world, with textures, shadows, and a history carved into its surface scars. And what if it doesn't behave as expected? Remember Oumuamua, the first interstellar visitor we ever spotted? It moved in ways that still baffle scientists, accelerating slightly for reasons we still argue about. Could 3I Atlas pull the same stunt? Could it carry secrets about the cosmic neighborhoods it's passed through, or clues about whether life's building blocks are common between the stars? Even Washington started paying attention. On July 31, 2025, Representative Anna Paulina Luna took notice. Representative Anna Paulina Luna pushed NASA to seriously consider repurposing Juno for this chase. Her message was blunt: if we can do it, we should. This isn't just about a probe and a rock from another star. It's about seizing the moment with the tools we've got. Because moments like this don't come twice in a lifetime. Do we turn away, or do we follow? The clock is running out. Here's what's on the table: a dying spacecraft with almost no fuel, a cosmic visitor that won't wait, and a narrow window that snaps shut forever if we hesitate. If Juno makes the move, it won't be for a slow rendezvous. It'll be for a fast pass, just minutes, maybe hours, when 3I Atlas flashes across our view. Enough time to map ice and dust, enough to listen for the faintest whisper of gas, enough to measure the tiniest, telling change in its motion. Taking the shot means trading certainty for hope. It means risking the last breath of a veteran spacecraft to reach for a question we've carried since the first humans looked up at the night sky. What's out there? How often does it pass by? And did anyone mean to send it? But this isn't just about 3I Atlas. It's about the privilege of standing at the edge of the known and stepping forward. Every interstellar object is a messenger, carrying the physics, chemistry, and history of a place we will never visit. They arrive uninvited, unplanned, and they never stay long. We can't send probes to every star. We can't explore every distant world. But sometimes, the universe sends one to us. And when it does, the choice is clear. Open the door or watch it vanish into the dark, knowing it will never knock again. Exploration has never been convenient, and it never will be. The debate inside NASA is heating up. Engineers run simulations day and night, plotting possible burns, calculating every gram of fuel, every fraction of a second in timing. The numbers say it's possible, but only just. A single miscalculation, a sensor glitch, even a slight delay in the burn, and the intercept window slams shut. The stakes couldn't be higher. In one corner, risk-averse voices argue Juno's last moments should be spent gathering more data on Jupiter, something guaranteed to succeed. In the other, the bold say it's worth gambling everything for a shot at history. No middle ground exists. The decision is now or never, and each day wasted tilts the scales toward never. Public curiosity explodes once the idea leaks. Social media lights up with hashtags, Catch the Visitor, Juno's Atlas, turning a quiet mission extension debate into a global spectacle. Artists post wild concept art of Juno streaking toward a glowing alien object. Talk shows speculate on what it might be: a frozen shard from another sun, an ancient comet carrying the building blocks of life, or, more sensationally, a long-forgotten alien probe. scientists cringe at the hype but can't deny the truth. 3I Atlas is more than just rock and ice. It's a messenger from beyond, and this could be our only close-up for centuries. Behind closed doors, mission planners dig into the fine print. Juno wasn't designed for this. It's old, solar-powered, and battered by years inside Jupiter's deadly radiation belts. Its cameras and sensors are aging, some degraded beyond repair. The spacecraft has no backup systems for a deep space chase. And yet, the very fact it's still alive makes it a survivor, a proven fighter against odds. If there's one bird that can pull this off, one engineer reportedly said, it's Juno. The statement spreads through the team, becoming a quiet rallying cry. Hope, it seems, is just as contagious as caution. Meanwhile, astronomers worldwide keep watching 3I Atlas, tracking it as it blazes through the outer solar system. Every week, the numbers tighten, its exact size, spin, and trajectory becoming clearer. Early readings hint at unusual brightness patterns, almost like its surface reflects light unevenly, suggesting cliffs, craters, or plumes of gas. If that's true, Juno's flyby could be far more than a photo op. It could reveal active processes, maybe even exotic chemistry not found in our own system. But every new detail is a reminder. The clock is still ticking, and the object isn't slowing down. By late summer 2025, all eyes are on a single date, September 9th, the day Juno must commit. Once the engines fire, there's no undoing it. The maneuver will fling the spacecraft into deep space for the final time, bound for a rendezvous with something humanity has never touched before. If it fails, Juno will drift into silence. Its last act, a gamble that came up short. But if it succeeds, for a few breathtaking minutes in March 2026, we will stand face to face, across millions of kilometers, with a traveler from another star. And in those moments, we may learn more about our universe than in decades of waiting. September 9th arrives. In mission control, the room is silent, every eye fixed on the telemetry feed. Juno swings into its deepest dive toward Jupiter yet, skimming just above the roiling cloud tops where lightning storms rage bigger than Earth itself. At the exact second, its main engine roars to life. The burn is perfect, clean, steady, and final. There's no going back now. Juno is flung outward at blistering speed, leaving the gas giant's grip forever. For the next 6 months, it will coast through the frozen dark, alone, chasing a speck of light that isn't from our sun. And somewhere out there, 3I Atlas keeps racing toward the meeting point, silent, ancient, and carrying secrets from another star. The countdown to March 16, 2026 has begun, and the world is watching. It's not efficient, it's not cheap, but this is how we've always learned who we are and where we stand in the endless dark of space. Do nothing, and 3I Atlas slips back into the void, and the silence wins. The chance won't come again, not for us, maybe not for decades. For as long as we've existed, we've looked up and wondered if we were alone. Now, the universe has answered, not with words, but with a rare alignment of time and trajectory. This isn't an invitation we can reschedule, it's not a promise. It's a fleeting knock at our solar system's door, and it won't knock twice. This is the line between silence and signal, between staying home and stepping out into the void, between watching a shadow fade and daring to aim our instruments straight at it. If you want to follow this chase into the dark, subscribe and leave a like. It keeps the signal alive and tells the algorithm to let more people hear it. And if you want to stand even closer to the heart of this mission, become a channel member. You'll be part of the crew keeping this journey alive, searching the skies, telling these stories, and sending this signal further into the unknown. Right now, there are no special perks, just the shared knowledge that you're one of the few keeping the hunt alive. But soon, we'll find ways to bring you something extra, something only our closest allies will see.